this video, we'll look at the algebra topic of adding and subtracting rational expressions. Here's the example that we're going to work on. 5a over 3a plus 6 minus a minus 1 over a plus 2. When we're adding fractions, for example, 1/2 plus 1/3. Do you recall that you need a common denominator? Now the common denominator in this case would be 6. So I'd multiply the 2 times 3 to get 6. And I'd multiply the 3 times 2 to get 6. And to apply the multiplicative identity, which what that means is when I take anything and multiply it by 1, which is a multiplicative identity, I just get that anything back. So if I take a 7, multiply it by 1, I just get a 7 back. I'm going to take this red 1/2 and multiply it by 1 in the form of 3 over 3. 3 over 3 is equivalent to 1. So when I multiply 1/2 times 3 over 3, I don't change its value. In the same way, when I multiply 1/3 times 2 over 2, I don't change its value because what I'm actually multiplying by is 1. And anything times 1 just stays the same. Its identity doesn't change by being multiplied by 1. So these numbers change. 1 times 3 is 3, 2 times 3 is 6. So we have a 3 over 6 plus 1 times 2 is 2 over 3 times 2 is 6. Now that I have two common denominators, the 6 is common. Now that we have that common denominator, I can add straight across, so add the 3 plus the 2, and that's going to be over, not 12, but over 6. So you keep the denominator the same. So we have 3 plus 2 is 5 over 6. If we had gotten a fraction that needed to be reduced, the last step would be to reduce it. Let's look at this example we have. 5a over 3a plus 6 minus a minus 1 over a plus 2. First thing we need to do is find the, I'm going to say least common denominator, but in a pinch, even a common denominator would do. It's going to be to our advantage, though, to be able to find the least common denominator. So I'm going to take this 3a plus 6 and factor it. When I factor that, I can factor out the GCF 3, and I'd have 3 times the quantity of a plus 2. And then I'm going to take this a plus 2, and, well, it doesn't factor, does it? But notice how it's common. That a plus 2 is common to both of those. When I go for the least common denominator, you have to be careful with that wording, because it's not the smallest of the different factors. It's the smallest that it's the smallest number that these can both go into. So here's how you come up with that least common denominator. We're going to start with either one. Let's just start with this 3a plus 6. We need, for that 3a plus 6, a 3, a factor of 3, and a factor of a plus 2. So we know that our common denominator, our least common denominator, must include a 3, and it must include an a plus 2. Now when I move on to the a plus 2, we need an a plus 2. But look, we already have it, so we don't need it again. So our least common denominator is going to be 3 times a plus 2. That's the first step. Find the least common denominator. Watch what I'm going to do next. I'm going to write this 5a over 3 times a plus 2. All I've done is, number 1, I exaggerated that fraction bar, and number 2, I factored the 3a plus 6. Be careful of this minus, by the way. We'll see that popping up again later. But we're going to subtract a minus 1 over a plus 2. I'm going to put the numerators and denominators that are terms or expressions like a minus 1. I'm going to put these expressions, the a plus 2, a minus 1, a plus 2, I'm going to put those expressions in parentheses, and I've exaggerated the fraction bar. Now we need a denominator of 3 times a plus 2. This first one already has it, 3a plus 2, so we're okay there. But for the second fraction, you see that we need a 3. In order to have 3a plus 2, we already have the a plus 2, we need to multiply in the 3. Now if I put a 3 in the denominator, I've changed the value of this fraction. By multiplying a plus 2 times 3, I've changed the value of the fraction. But if I multiply the a minus 1 times 3 also, I'm really just multiplying by a big fat 1. Because that 3 over 3 is 1. So I'm not actually changing the value. I'm multiplying a minus 1 over a plus 2 times 1. All right, we are all set to go. Now we'll just go through and do the adding. So we know that when we add this, the denominator is 3 times a plus 2. No need to multiply that out. I'm going to leave it in its factored form. But watch out what happens here. We're going to have 5a. I'm going to use a red pen for this minus 3 times a minus 1. Order of operations tells me I need to multiply before I subtract. I need to multiply this 3 times a, multiply the 3 times negative 1, or in other words, distribute that. Here's what it would look like. So this is all going to be over 3 times the quantity of a plus 2 still. And we still have our 5a. But watch what's going to happen. I'm going to show you what you want to be careful of. 3a, and then 3 times negative 1 would be negative 3. But do you see what's wrong with that? Because this minus went to the, this minus has to distribute to the a and the negative 1. Here's one way to think of it. We're going to multiply or distribute a negative 3. So negative 3 times a, we're good here, it's negative 3a. But negative 3 times negative 1 is going to be plus 1, not minus 1. Do you see that? It's negative 3 times negative 1 is positive 3. And now we're set to do the arithmetic. That's the hard part, what we've already done. Now for the easier part, we're going to take the 5a minus 3a is 2a, so combine like terms, plus 3, and that's it. Now you might be tempted to say, oh, but there's an a over an a. Can't I reduce that? No, we're not going to reduce that because we can only reduce when there's a factor. So if this was a 2a times 3, then we would be able to reduce the 3 with the 3. But when it's separated with a plus, you can't break into it. It's as if that sum, the 2a plus 3, is in parentheses. It's not a factor. And that's it. There's the answer to that first question. I hope that that short video has helped you. If you do have any further questions about the problem, please don't hesitate to reach out to me and let me know how I could help you better understand subtracting and adding rational expressions that don't already have a common denominator.